Allora, good afternoon, everybody. Buon pomeriggio a tutti. We are mixed classes, so we have Italian and English classes today. So I'm very proud, together with Professor Omar Al-Shawa, to host this today's seminar that will be held by engineer Francesco Del Tosto, who is here. For us, it's an honor because he participated for the design and the construction of the Garbatella's bridge, Settimia Spizzichino's bridge, which is an iconic structure that today we will discover together. And he's also leader of a professional office in which very big works are carried out, starting from the Piacenza's floating bridge, which was built some years ago. It's also a very relevant and huge structure from an engineering point of view. It has many interesting aspects to discuss, and also the Baghdad's bridge. So Engineer Francesco Del Tosso has an international experience that is very precious to all of us. And so we want to warmly welcome Engineer Del Tosto to today's seminar.
It's better to have after the lesson good afternoon, Francesco Del Tosto, my name, and I'm an engineer. I wish to thank Professoressa Giresini for his invitation. And what we are doing today is not a lesson, but I hope that could be an experience to share information or to give some information or tricks of the trade about how to design and to produce something that is not normal, or to push towards a new structure and some new and relevant particular design. And so I hope that after my presentation, we can have a discussion about some items that can interest you from a student side, and so we can see the. Questo qui, come va?
Sì, posso. Aspetta. Mamma?
Ecco.
Sì, doppio clic. Dopo te lo mando avanti io.
Garbatella Bridge maybe is already known by you, and is in the south of Roman downtown, and is andiamo avanti così?
Sì.
Okay. Is between two areas, Garbatella on the west side or east side, yes, and Ostiense on the west side. Garbatella was built, or the Garbatella was built in 1920s, and is a garden city. They work an area for workers, and on the other side there is Ostiense that have some warehouse and workshop, because the river give the opportunity to bring the material by ship. And so there is, for example, the gasometers, that is an iconic structure, as you can see on the left of that represent the iconic element of the area. The gasometer is now is the remnant of the steel tank that contained gas, and the gas was done by pyrolysis, with the coke arriving by ship. It means that now is an element important for qualifying the area. For sure, all the area now is under urban regeneration, because what was also the general market and also other warehouse are now changing their destination. And
questo bisogna darglielo.
okay. Yeah, there is some idea of what was Garbatella and Ostiense some years ago, and so an industrial area.
Il indietro funziona. Vediamo se funziona anche la
Okay. What we want to, we have to analyze why we arrive at this shape. And first of all, we have to analyze the situation in which the bridge have to be built. And there is three elements that represent the constraints of the design. The first is that from the east to west, the two carriageway that belong to the circumvallation Ostiense, they merge in one carriageway going to Ostiense. And so there is a V shape in planimetric vision. And it means that we have a double deck on the east side and one deck on the west side. Also, we have one element that represents another constraints of the situation of the area. That is the Almone River. Almone River is a tributary of Tiber on the left side, and is in Caffarella Park is a river. When across the city, it was put inside a big duct. And so we have a duct with the river inside, under the bridge. And so this was a very important constraint. And this presence reduce the capability to arrange a simple and normal viaduct, because was very impactant on the planimetric, the shape or the presence of the duct is like 6 meters diameter, maybe more, that cross under the bridge foundation. Also taking consideration that I put sparkling water because the water of Almone is almost sparkling, coming from the volcanic area on the east of Rome also. Andiamo avanti.
Laggiù. Entro questi.
Here there is a planimetric alignment with the sovrapposition between the foundation and the duct that is under the foundation. And also another characteristic is that the east side of the bridge have 6-8 meters above the west side because the fourth track of the metro on Roma Ostia divide the area in two sides, and also the Garbatella side is on an upper level, almost 7 meters up. This create all these constraints, create a different and asymmetrical situation for the bridge. Okay, and also the V-shape represent an important constraints for the definition of the entire structure. This was the initial proposal by the municipality. As you can see, there is one rendering that represents an arch like Y shape, which the nose was towards the Garbatella, and was characterized, this preliminary design, by a concrete huge arch, and also, as you can see in the following section, yes, on the left there is the preliminary design of this concrete bridge, and on the right side there is our proposal or our design. It's important to note that the verticalization of the rope allow to reduce the deck width. It means that the load gauge have to need a space, need a volume for transit. Okay, so have a verticalization of the rope allow to reduce the width of the deck. This was done with increasing the width of the arch, with this joke of open the arch with a double element. Also here there is the preliminary, our preliminary proposal, and second is a picture of the real situation. As you can see during the detailed design, we have to modify a little bit and to define the structure. The first was a first impression of what we can do. And so an intermediate, our preliminary proposal. After we checked that there was some torsional problem, and so we enlarged the nose of the Garbatella site. Sorry, I don't know if it's quite simple to follow me because my English is not so good. Also, I speak in something that can be quite weird. But if there is any problem, you can. I can try to speak Italian, but the situation cannot modify. The microphone? Okay, maybe it's better. Okay. So it's not it's only a problem of distance. Okay. This is quite simple. And okay. And yes. Here there is one joke that represents what we fuse la Barchetta Bridge in Siviglia, and some toys. That period I have my children that was very young, and every day I was playing me too with this kind of. And I think that is very interesting to have this kind of image because, for example, our bridge now would be very easy to design this, but 20 years ago, when we proceed with the definition of the design, was very difficult to have a good management of 3D structure. It means that was because in our office there was some good guys that was able to manage 3D, that we was able to do this. Otherwise, if you have not the tool, for example, this kind of bridge was quite impossible 40 years ago, because we have all connection between the truss that are different for geometry with different angle and so on. And so if you have not a 3D model of the system, you cannot produce this kind of, is a nightmare to produce this. I joke, but it takes more time to design this than to build this, because to do every truss is different for dimension and for angulation and so on. But to build this was more simple, because when you have the sketch of each different plane with different element, is not so difficult. And so this is...
No, c'è un problema di visualizzazione, scusa, mi sta correndo. Ok?
Gigrobo. E quindi... And so this is really the product of 3D software. Is clear. If you have no tools, you cannot do something, and everything is related. But there is also a necessity to do this. Is not an idea, abstract idea, this shape, but as I told you before, the shape was chosen by the necessity to verticalize the rope and to create this. Ok, possiamo andare avanti. And you can see from this picture that how is complex for previous design tools to arrange this kind of structure. This is like also zoomorphic. We have some reminiscence of something from like a fish, like a cobra. You can see whatever you want in this. is also became a joke, yes, but not only a joke, but when you fuse the techniques and something that can be funny, I think that you realize something new. Yes. So now we can discuss about how we this is some dimension characteristic of the bridge is a double deck or it is two separate deck and is linked together by truss. Tomorrow we have the chance to go also below the deck and it's interesting to see the structure and the different alignment and different elements. For example, here you can see that the verticalization of the rope allowing for the pedestrian to not be intersect by the rope. Also, there is a problem for the guardrail. You have to take in consideration the deflection of the guardrail, and so you cannot put the tie rod very near to the guardrail. Otherwise, when there is some incident, the deflection of the guardrail can cut the tie bar. And, Okay, here there is how work the chain because the static scheme of the bridge is with the blue point means l'incastro that is
Fixed support.
Fixed support. Yeah. It's fixed support with a very huge road. We have 76 centimeters, maybe bar, 2 meters high, like bolt, very huge bolt that fix the nose of the structure. And on the other side, the red point means two bearings that have the capability to move in two different directions. In this case, it's important to link the hand of the arch by a chain. Otherwise, you have you cannot control the deflection and the movement of the arch. And so we realize like a chain in the yellow dot line you can see. Tomorrow we can have the capability to check this chain that constrain the arch. They are under the deck. It is something unusual, but also the shape of the arch characterize the overall design of the bridge. And as I tell you, you can see a lot of things on this, but it's only a joke. It's something that became very funny to modify and to bend the arch. The arch is done by right segment, but each segment have an angle between, and so what resemble a curved line is made by segment, right segment. It's important to know if you want to do this kind of structure to know very well how to manage the steel structure. It means that all the connection, the bolt connection, all the elements that can be done have to be on the respect of the state-of-the-art system. For example, the builder of this was Cimolai, and Cimolai is have the warehouse in the north near the railways. Also here we have the railways under the bridge, but it cost 3/4 to bring by railways all the segment than to bring the steel structure by a lorry. This is incredible, but all the steel structure came by lorry and without using the railways for. This is some drawings that show you the structure. You can see there is 3 beam, secondary beam. Each 3 beam there is one connection and one tie rod. It means the beam that you find, you see between the deck is step 7.5 and the secondary beam on the deck is 2.5. It means that there is each 3 beam, one is pass through the 2 deck. Tomorrow we can see also the node are different from the secondary beam without passing is an inch. If pass is a continuous beam. And so also the link, also the connection are different. I don't know how much you could be interested in the connection of steel structure, but is paramount in this kind of structure.
I am interested.
Here there is the foundation definition of the 3 foot, the right side, Garbatella side, is the fixed point, and the other are only bearings. This is some picture of the site during construction. This was the 2 foundation. On the right, we have the big foundation for the nose. On the other side, the foundation of the simple bearing. Here there is a definition of general view. And also some details. It's important when you build a bridge to understand how to build the bridge, because the bridge are the main reason to be that the connection between two sides, okay? It means that there is something in the middle that don't allow you to pass, okay? And so also when you have to build the bridge has to be built in the area where you cannot put your foot, okay? This is easy to understand. And so the way in which you build the bridge is sometimes paramount, or the most important element in the choice of the typology of the structure. In this case, for example, okay, we can after discuss that there was also the maintenance in the big pipe. They are hollow inside, and there is some stairs, and so you can check maintenance and inspect the inside of the bigger element. Also, in this case, the joint was like a flange. It means that there is a two or annular element, and you can pass through the joint. This is the external. This is the joint that can be passed by the inspector. Sometimes I happen to go inside this bridge, and it's a nice experience because when you go inside the structure, you can understand how much it's difficult. Queste sono different dimensions. Some details of the rope, details of the bolt connection of the nose, where three pipe arrive and have been interacts that allow them to bring the bending moment during the torsion of the bridge. This is some details that give an idea of how much complex was this kind of different joint. And so sometimes you have to understand if necessary to do all this kind of work for, I don't know. These are the connection are by cross. In this case, you have not to go inside the elements because are too narrow. And so the connection can be like a cross shape. Some details on on that side. You can see something where you can go through, and the other where you not allow the entrance or the inspection. Yes, here there is some, the lower arch have this kind of turbine joint, and that are masqueraded by some cutter. It means that sometimes you have to show the joint and represent an architectural element, otherwise you have to shade the joint. As I was told before, here is how we built this. The arch was built with temporary tower that are necessary and was possible because the railways area allow the positioning of these temporary towers. This is, but I want to underline that to build a bridge, the phase are usually more stressing than the final configuration. The construction phase usually are very important in definition of the geometry and of the structure. Particularly when the structure is so big that you cannot take with a crane and put in place in one shot. Yes. And so the arch was built on the tower, and the two leg in a triangle shape was built in the other side. And so there was the connection that required a lot of time, because each bolt have to be correspondent with the hole on the other side, you understand? And this was the most difficult part. for sure, this kind of structure can be done if you have a good manufacturer, a good contractor. Otherwise, it's a nightmare every day. Also, I have to wish to thanks my friend that passed away is Professor Francesco Bianchi that spent time in the lightening of the bridge, and now the maintenance is very poor, and so maybe you cannot see anything of what was done, but each tie rod was lightened by an annular element that give impression of like a shade. And now it's more normal, but 20 years ago was one of the first bridge to do this with lightning. That yes. Also here there is some little joke. The success or the appreciation of the bridge is possible to touch this success with some copy or some gadget that born. So on internet you can find this kind of shirt and so. This is at the end of the day. I think that what I suggest to you that are students, maybe you, that to do this kind of structure is important to have passion and a good master. It means that if you have the chance to learn this craft in a good studios or in a good office is paramount, because something can be learned at the university, but not all the tricks of the trade that can be learned in the university. And so it's important also to have passion for continuing researching and study of this kind of things. I don't know if you are interested in a bridge, but I think that a bridge is better than wall, and for sure is something that is interesting in from technical point of view, but also from a philosophical point of view.
Yeah, that's right. Thank you very much.
I bought one shirt on internet and I can be proud of, yeah, I can be proud of work this one.
Yeah, you have to be very proud. Shirts came up, with your own structure designed by yourself. So thank you very much, Francesco. This was an extremely interesting presentation from my point of view, because it's really plenty of aspects that would need to be really faced and investigated in a very specific way. So you've just passed through the slides without stopping so much and without discussing so much on each one of them, but I can ensure that each aspect that Engineer Del Tosto has touched is plenty of considerations and things that can be, discussed and understood and interpreted better and better. So. we can start the discussion now. So I hope that some of you have some questions, any kind of questions, right? They can be like questions about the structure, questions about the constraints that Engineer del Tosto has had to face before, during the design process, because we know that in structures we have specific phases. So we start from an idea, then we have to design that idea, then we have to adapt that idea to specific constraints that are really numerous, especially for this kind of structures that are iconic structures and that are willing to be iconic structures. So you have a lot of constraints, and then the construction phase that is extremely interesting in my point of view, because it has a lot of aspects to be considered. So I think we can talk a lot about this presentation, and I think that also Engineer Del Tosto will be happy to answer your questions. So yeah, please, the first one.
And I have a question about the maintenance of the structure.
Can you speak aloud?
To change some elements, how it's operated.
Ok. So chiede se per esempio vuoi cambiare alcuni elementi, alcuna forma di elementi, si può fare. But do you mean if you want to change some structural elements in terms of shape, for example?
Environmental damage.
Ah, ok, so to check. Ah, ok, se vuoi sostituire alcuni elementi.
Yes, a good question. In this case, it's important to analyze if one tie bar can be damaged or cut by incident and so on. And so the bridge have to resist the lack of one tie bar. And in this case, you can replace because it's something that you have to cut and remove and substitute with the tie rods. If there is some problem for the another interesting aspect is when you have all this kind of bolts, it's important to check if they are really fixed, and so this can be done with inspection and also with survey of the dynamical answer of the bridge. It was done a double analysis, one with analysis of the frequency of the bridge, and the other also one sophisticated analysis on the sonar wave issue by the deformation of the structure, but is quite experimental and complex system. But yes, however, everything can be changed. It means that if there is some hole for rust, for example, reduction of the thickness by rust, it will be difficult to repair, but the inspection is important in this case.
So you can substitute structural
substitute can be substitute the tie rods. Tie rods can be substituted for the steel structure. Yes, usually it's not necessary to substitute, but if there is some problem, you can reinforce with welding new part on the inside or outside.
So additional member like plates, for example, to strengthen.
But if you have to add something, it means that there is some mistake on the design, and so is more the problem is on the other side. But to change is possible tie rod in this case.
Okay, thank you very much. There is one person from home, Xentika. Can you make your question? And also there are some other questions from home.
Yes, thank you. I would like to first thank both of our speakers for the engaging presentation and also Professor Shawa for organizing it. And I have a question. The speaker was talking about the assembling of the elements, and I was thinking nowadays, can we like manufacture and assemble the elements in some other part and then bring them like together, maybe as bigger as sections in the site and assemble them? Would it make the assembling shorter? I'm talking for the site part. Like separate the bridge in different sections, assemble them in another area, and then bring these bigger sections and assemble them in the site.
Chiede se possono essere, se oggi la maniera di assemblare gli elementi è diversa rispetto a 20 anni fa, possono essere assemblati in parti più grandi, in un sito diverso, se cambia qualcosa di su.
Is any problem?
Ok.
Okay. Sorry. Not much, because for the definition of the joint up to now, this is like a craft, an art, the definition of the joint in the steel structure, but more or less remain the same. What can be changed is the way how you build the bridge that define where you have to put the joint, but the modification and the construction are not so speedy like other field of techniques. Now there is a more sophisticated sensor for definition of dynamic and for monitoring the structure, yes, from electronical and no, but not for the mechanical, more or less is the same.
Okay, good. So thank you for the question and thank you for your answer. Other questions? Yes.
How much redundancy was planned into the design? Like as an example, should a cable rip, how bad is it to be the structure?
Se avete previsto una ridondanza strutturale nella struttura, cioè se c'è qualche danneggiamento.
Yes. No, as I told you before, the tie rod can be changed, and so the structure can be safe without one tie rod. But in this case, the cost of the bridge is almost the cost of the steel, multiply for the unit cost. And so the problem is that you have to, from one side, reduce the weight, the overall weight, and also the weight of the steel, because it's the cost of. And so you cannot allow to have a very huge extra thickness, for example. But yeah.
So we have a certain degree of redundancy, basically, in the sense that if we remove a tie rod, the structure remains stable, at least for some time.
Yes, but only for provisional.
Of course, for temporary works, yeah. Okay. Yes. So another question here.
Part that has been thrown, like I think the original rendering was only one section.
Yeah.
Two. I want to know like why the design changed.
This one, just a moment, I find the slide you mentioned. Chiede, come mai è cambiato
No.
troppo?
Yes. This was not normal structure, and so when you have to define a building, usually you have a beam, column, and so on. And in this case, we have a preliminary idea of what could be the statical and dynamic performance of the structure, but also because it was like a proposal for the municipality. Okay, when we fix all the system and analyze the horizontal force made by the wind and the seismic load, we understood that there was some torsional problem because if you check if the two deck starting to flip to modify their and you cannot be able to manage the bending moment of the nose. Okay, and so the nose have to be more resistant to the bending to the lateral deflection of the deck.
So you had to basically split this unique element into two.
Yes, and also one other very critical point was this node that in this case was like an hinge and was resolved with three elements that became four. On the leg you have two bigger elements and two secondary that represent the stiffening and the central arch, the part and complete on the bigger. That node require a lot of time. And,
Yeah, but that's very complex
yes, in this case.
decision, you know, to adapt the first solution. Yeah, thank you.
Also, for example, depend also on how you can model this and how you can solve the problem by software. Okay, if you have a preprocessor that is quickly change the geometry, you can imagine this done by numerical point of view. You have to modify a lot of number, and so more.
A lot of inputs.
Yes, the problem of design is you need the correct tools to do something that is manageable.
Instead, in this case, since the structure is really complex, so it's not just to explain.
Yeah, absolutely.
It's not a frame structure, you know, so it's not an ordinary truss structure. So basically, every node is different one from each other. So it's very difficult and complex to change the geometry, the input geometry on the software. Yeah.
Yes, also because when you do the design, you have a preliminary idea of what will be the tactical behavior of, and so, for example, you have one column, you can analyze the area that refer to that column and understood more or less which is the vertical load acting on the column, okay? But if the more the structure is complex, more difficult to have a preliminary design, a preliminary formation about and there is a cyclic system process. Yes, you have to first of all you have to know the behavior of the structure. Otherwise, you invent to like blind. operation.
Absolutely important, and we say it very often in class that first of all you have to understand the static scheme, and then you can implement your structure in the software, because otherwise it's absolutely nonsense. So you are not a designer, you are simply someone who puts the structure inside a computer and let's run the analysis, and then what it comes up, we are not able to interpret. So it's important that we have a preliminary idea of the structure. And indeed, I have a curiosity about that, but I will ask it later. Okay, so before I want to ask you if you have other questions. Yeah, please.
Actually, similar with the concept that we taught. Let's say for transducer, it's a complex design and that can consider as like a moment. But I want to know at which point we decided not to follow the traditional methods like trench structure, but have more complex design, to have more modern design. I don't know if you have decided at the beginning to choose it, or you were pushed to choose it by the conditions.
Significa perché ho scelto questo tipo di
Sì,
struttura.
esatto,
insomma,
non
sì.
una più tradizionale.
Depende. Depends on your. If you like to do something new or to push forward, you are. My personal attitude is to push to something that would be more interesting. Okay, but for example, we base the starting point on the Y shape made by the municipality preliminary design. It doesn't work because was the deck too large and too heavy. And in this case, we need to verticalization of the roof. For the verticalization, I remember I was under the shower in the morning, and I think, I can do not one arch, but two arch, okay, and to modify the arch. And so came some idea. When I present this to the municipality, because I have some internal contact and so on, he told me that, oh no, never they allowed you in Rome to do something like this. It's bigger than San Pietro. What are you doing? But I insist, and so I win. It require a lot of understanding of all the situation. You have it's like not a gambler, but when you play card, you have to know what you can do and what you cannot do. In this case, it was important to risk something to modify the usual design. You can imagine to do a big concrete arch that was quite huge, very heavy, and not. And so when you start to thinking that to do something, it will be more expensive from time point of view. But if there is a passion, you continue to thinking about how the solution can work, and this continuing allow you to discover something. This is an attitude. It means that yes, I can also. Maybe also the municipality did some mistake because they wasn't able to manage the design, and I put the foot on the door for this. This is what happened in this case. For example, when I did the floating bridge in Piacenza, it was possible because one bridge on the Via Emilia collapsed, and it was one important road crossing the River Po, and they don't know how to manage the temporary connection because there was the city one side and the industrial area from the other side. And so they asked for a solution. I invented a floating viaduct with link and other things. Maybe we have the chance to show you this in another seminary. But this seminary was sold out, and so maybe we can replace. And so in this case, I did something that was not normal. And so sometimes it's important to push, not every time, but to check if it's possible to have if there is space for innovation. Yes, you have to be ready to push. Is something that requires balance, also knowledge of other solution. In this case, there wasn't the other solution after. But remember that if you want innovative, you will have a lot of people against your idea. Because not to explain these kind of things, but it's like in the life, if you want.
They are all future architects, so this aspect of creativity and play with intuition and increase your passion on what you are doing is crucial, for making special things. So we said in the very first class that they all have to think about building something special in their profession,
No, but I think that also when you are young, you have to push in this direction. But more more your innovation is feasible. Otherwise, is something like picture, not construction. You understand? Sometimes there is some creations that are without capability to be able to be built. And so to have the knowledge of the technicians and the innovation of the young and so on. But it's hard work. Require a lot of require passion. Require a lot of analysis. Go back and down.
Many years of experience.
Yes, also a good luck. Good strike luck. Yes, this is important in the life, in professional life also. When the opportunity arrives, you have to grasp. Otherwise,
it's true. It's true. Some other questions also from Italia. Yeah, you. Prego.
Allora, premetto che forse scrivere una domanda però.
Non diamo voti.
Allora, e lo stato rifatto, mi chiedo come è passato da come è stata proposta all'altra, sembrano due posti completamente diversi. E anche la sezione di quello dei posti è del doppio di quello che aveva previsto non lo so, io effettivamente sembra
Assolutamente, sì.
risparmio dalla proposta, come è passato da una all'altra, perché sono tanto diversi.
Sì e no, nel senso che comunque abbiamo mantenuto, questa era una proposta preliminare, insomma non era chiaramente una soluzione definitiva. Sorry for the Italian, I don't know if I have to speak English, but interlocution in Italian. Sì, ti scrivo. Let me speak Italian. Però si è passati attraverso una variante che teneva conto di altre situazioni per il fatto che era cambiata la normativa e quant'altro, e comunque l'ipotesi era, insomma, abbiamo mantenuto quel progetto, però quando si fanno questi tipi di soluzioni era una proposta abbastanza basica, insomma, anche gli altri avevano fatto delle proposte molto più...
La domanda mi sorge anche che cosa di piazza, ma questo era necessario fare così grande in quel posto. Infatti comunque la proposta Ranger mi sembrava...
Sì, però il progetto a base di gara era ancora più impattante perché era un grande arco in cemento, insomma, quello noi abbiamo fatto in acciaio, abbiamo alleggerito, poi chiaramente le dimensioni. Beh, sì, si poteva fare anche chiaramente il viadotto normale o cose del genere, però poi alla fine penso che sono stati buttati molti più soldi da altre parti, tipo, e rispetto... No, no, perché invece diventa, ecco, come costo non è stato, insomma, rispetto ad altri, vedo che insomma, adesso c'è il progetto del ponte alla Magliana. Quello è un'altra...
Great. Other questions in Italian or in English? It's okay, absolutely fine. Curiosities or doubts or something else? Try to take inspiration also from the classes that we did together. So maybe since today I explained the arch, part of arch, so so maybe you have some questions about the arch, and we also analyzed steel truss structures. So here we have a combined structure, which is an arch, and at the same time we frame a truss structure. So do you have some questions about that? Yeah?
Can you repeat any examination on the bridge to see if orders or not? Or they just cross the calculation?
Prima di aprire il ponte avete fatto il collaudo, sì.
Yeah, so for the verification, so sorry, you asked for the verification? Yes, the code required that you have to do the test. And so there is a test on the deflection and on the vibration of the structure. Absolutely, yes, it's important and necessary. Also for the bearing load, the capacity of the pile. I can tell you this story that the contractor don't believe that they can do like a pile not so deep because there is some gravel after 15 meters, and I believe that the pile wasn't very. They don't need a very deep pile. And so they did one like official fake test, and they verified that effectively before the official test, they did one test of the test, you understand? And so, because usually in geotechnical, you have more difficult in the definition of the load. For a steel structure, usually the certainty of the calculation is more reliable. With geotechnical, you have a bigger difference between the reality and the hypothesis. I don't know if I am clear, but for the geotechnical also because you have different kind of soil depending on variation of geometry or
Yeah.
But for example, also a friend of me did the analysis frequency of the bridge, you put some accelerometers on the structure and wait that the wind can move the bridge. When the bridge move, you can analyze the frequency of vibration. And there was very, very good correspondence between the theoretical number and the registered one, and so.
Because below the bridge we have the train.
Also the train, yes.
So the train are passing below the bridge. So there is a big problem about vibration analysis as well. So the serviceability limit state that we have seen in class that apparently is not so important, for the survival of a structure, for the safety of your structure. In this case, for example, this serviceability limit state is fundamental because you cannot have too many vibrations. So you have to keep the vibrations under a specific threshold, right?
Yes, also for the seismic, because the seismic action acts on a specific range of frequency, and so it's important to analyze if there is a resonance or not, or there is interference between the seismic and but for example, for the test on the deflection of the steel deck, here wasn't a big problem. But I can tell you that when we did a floating bridge, we registered 20 centimeters more of deflection, and we didn't understand why it is happening between at the beginning of the test and at the end of the test. The deflection was 20 centimeters. It was very huge. We didn't understand that. After we realized that for the fact that it was a floating bridge, the river in the meantime was, the level of the river was down 20 centimeters. And so the bridge could...
I imagine the moment you realized it, finally. Okay. So in this slide, I want to stress out, because tomorrow we'll be on site. So it's very important that all of you understand the main is a kind of roller, we can call it roller, right?
Yeah.
Carrello.
Sì.
Even if it has some stiffness in the translational direction. So it can move, basically. This support can move. So this is important. Then the arch, as any arch, applies a thrust force at the support, so it tends to open, right? So the arch, the static skin tends to open, and as Engineer Del Tosto just said, we have here a solution which is very smart from my point of view, that it stands in placing like a very huge tie, right, to reduce this thrust force that tends to open the arch. If you want to add something about this.
No, maybe tomorrow is your turn to have a question, because Professoressa will ask the behavior of,
right.
of the arch. No, but tomorrow we can see the structure and discuss the why and how some element or some details work. I think that is important for. Also, for example, the color. The color white was chosen by the municipality. They didn't speak up anything about, they don't interfere about the structure, but for the color was a big discussion internally.
Yeah, the color is impacting, yeah. Good. Some other questions? If not, we warmly thank you. So it's a great opportunity, I think, for all of us, because to have here a structural engineer who knows very well Rome and did this so important works all over the world. I think it's a very good opportunity, and we can be grateful for it. So thank you again, and see you tomorrow. Please be on time, because at 9 we will start our visit, and then since we will move as a group, we are a big group, so we will move in many points of the bridge. So please be on time. Professor Alshawa, you want to add something? Okay.
Maybe it's better to see at the entrance of Metro B.
You're right. Yes.
The Garbatella side.
When you go out from the metro, right?
Yeah.
The last time.
Siamo studi con uno che un ragazzo indiano, per cui alla fine dobbiamo sempre parlare inglese, perché lui non ha imparato l'italiano. Ora sta in prima. Beh, è stata ragazzi. No.
Ci vediamo domani.
Scusate.